background in versatile industries in the past. As Arindam was mentioning earlier, that we come from different industries and work together. I mean, that gives us an edge in a way that we can always apply an experience obtained from a certain industry to any other workflow, which is completely different, coming from completely different industry. And that really gives us an advantage over many other groups who are trying to do these type of works. Anyway, today's presentation is mostly about talking about Abaqus Knee Simulator and how these can help in your work, and how can we help with that. So let me quickly go into that and show you a bit of flavor of what Abaqus Knee Simulator is. So we call it AKS, and if I'll be using AKS mostly throughout the presentation. So AKS is an automated modeling tool for building advanced knee implant simulations based on a validated framework. So I mean, we have 5 different workflows within AKS, which I'll be talking about very quickly in a few slides. But the point is that all these workflows are actually validated with available literature and a lot of experiments conducted by different groups and research people. So the workflows which I'll be talking about today will be contact mechanics, implant constraint, tibiofemoral constraint, wear simulator, and basic total knee replacement loading. If by any chance you are familiar with Abaqus, the knee simulator design or the knee simulator creation of geometry and setting up the model is done in Abaqus CAE, and the solver is Abaqus explicit. So here, the dialog box on the left, which on the left side you see, has got 2 tabs: knee parts and test suites. In knee parts, we actually import the geometry, mesh it, and make it available for the setting of the model to perform the analysis. And in the next tab, which is the test suite tab, we decide or we determine what parts will be included in a certain workflow which we'll be doing. For example, if you are doing anything but basic TKR loading, then you don't need the patella part. And then next thing will be, of course, to determine what workflow you want to do on the implant design which you have. And once you click on the create button, which you will see on the left side, the entire setup of the model is done by AKS automatically. If bones, cartilages, and all these structures are required, then those will be included by AKS automatically. When I say automatically, that clearly means that we have bones, cartilage, and all these structures are available within AKS, which is a right knee structure. But that doesn't mean that you can't do a left knee implant simulation. The left knee implant will be mirror imaged and will still be simulated using the right knee setup. Right, I mean, once the model setup is done, you request what type of outputs you want. You define all the simulation options, which include the pre-strains on ligaments, what will be the stiffnesses, you scale up stiffnesses and all. You can also provide the muscle properties. When you put all these implants together, they may not fit exactly on the bones, or they may not be positioned exactly on the bones where you want. So you have the option of shifting the bones so the positioning is accurate. And once you are satisfied with all the simulation options and the model setup, you run the analysis. And then if you see a calculator button here, once you click on that, AKS will provide or do the calculation for you for all those outputs which are required from a certain workflow, but are not available by default within Abaqus CAE. So that makes the life very easy, that all the post-process task is actually done by the AKS, and you really don't need to write any scripts or anything for that. So as I was saying earlier, all the workflows are actually validated by experiments, available literature, uh, which includes, of course, the contact mechanics and all other workflows which we have. Here we have an example, a paper from Knight et al. In 2007, it was published, and they actually compared uh, the workflow and the results for a VR simulator. Which the experiment was done, and then the results were compared with the simulation done within Abaqus. So let's go into the AKS workflows, what we have and what exactly they do. As I mentioned earlier, we have these 5 different workflows, and these are being refined in the later stages of the FDA's medical device diagnostic tool program. So the first one, which you see on the screen, is the contact mechanics, where the contact during flexion is actually analyzed. As you can see, only implant components are included, and a load is actually applied. A compressive load is applied at different flexion angles, and the contact is determined. Here, you can actually select to have your insert as deformable or rigid. The platform on which the insert is resting can be fixed or rotating. Then you apply the compressive load, and that compressive load by default is divided 50-50 on the medial and lateral side. But you can use the slider here to change the proportion of loading on medial and lateral sides. And then you determine at what angles do you want to apply the load and find out the contact. You have the option of selecting that whether medial, lateral, internal, external, and varus valgus rotation of the femoral component is fixed or free. And once the analysis is done, the outputs which you'll be looking at will be the contact area, peak and average contact pressure, stresses in the components of the implant. Another workflow is implant constraint workflow, where we analyze the laxity between the femoral and the tibial component. And this laxity is analyzed in the absence of any soft tissue. In this, again, you have the option of analyzing the laxity at different flexion angles, where you have 3 different motions available: the anterior posterior, internal external rotation, and the medial lateral displacements. All these rotations are provided as displacements, and the outputs which you will be looking at will be the kinematics, the force, contact mechanics, and stress data in the implants. The third workflow which we have is the tibiofemoral constant workflow, where again we are actually analyzing the laxity, but in the presence of soft tissues such as ligaments, bones, and all. The workflow includes femur and tibia bones, femoral and tibia components, plus 1D or 2D representation of the primary ligaments crossing the tibiofemoral joint. Here, you have a few additional options. For example, you can selectively choose to exclude ligaments, which are either surgically removed or they are clinically weak. Again, in this case, again, the motions we are looking at are AP, internal, external, and the varus valgus torque. In this case, the loads are applied as force. Maybe if you remember, the previous workflow was displacement control, but this is a load control analysis. And here again, you have the option of providing the pre-strains within different ligaments you have. And you have also the option of scaling the stiffnesses of all these ligaments. We don't provide nonlinear stiffnesses, but we do provide the scaling option for these ligaments. And yeah, as I was mentioning earlier, when you put implants, they may not position exactly where with respect to bones, and that's why you probably need sometimes to shift the bones a few millimeters here and there to do the setup accurately as you want to. Once this analysis is done, you'll be looking at outputs such as 6-degree freedoms of kinematics, ligament forces, insert forces, stresses, and contact mechanics. The fourth workflow which we have in AKS is the wear simulator workflow, where we predict the wear on the tibial insert over a number of gait cycles. Femoral and tibial components are included, no bone or soft tissue. So this is a replication of the experimental setup in a lab, where we do provide equivalent parameters of the actual wear tester. For example, the gap distance here, and then the linear stiffnesses of the springs attached on the anterior and posterior side. We have two wear algorithms available, Archer's law and cross shear law. Archer's law is actually an isotropic wear law, whereas the cross shear, in the cross shear law, the wear changes according to the change in direction between femur and component, femur and the tibial insert. And yeah, the outputs you are looking at once this analysis is done is, of course, the wear into the tibial insert over a number of cycles. For example, here we are looking at wear after 5 million cycles. The last and the most complicated workflow we have is the basic total knee replacement workflow, where we analyze the whole knee joint mechanics during different activities of daily living. One additional thing which is included in this TKR workflow is the patella side. So we actually include along with the femoral and tibial bones and components, then 1D and 2D soft tissue representation. We also include the patella bone, patella implant, patella tendon, and quadriceps. Right. So here, as you can see, a number of daily life cycles are actually available here. For example, gait, chair rise, deep squat, step down, and default loadings are also provided, which are taken from ISO standards. But you always have the option of editing those loads based on the data which you may have with you. And once this analysis is done, of course, the outputs which you are looking at will be the kinematics in GS coordinate system, contact areas, contact pressure outputs, and all this. All other options in this workflow are similar to what we saw earlier. For example, changing ligament properties in terms of pre-strains and linear stiffnesses, muscle properties, shifting bones, and all. Right. So I have one slide on the value proposition, where we have the comparison between it's basically the ROI which you can look into. So for example, for the contact mechanics, you can see that the workflow which in a lab can go up to 4 weeks. You can do that AKS in almost 2 hours. Similarly, for the implant constraint, the time can be reduced from 4 weeks to, again, 2 hours. We don't have the time available, or there is no equivalent standardized test available for tibiofemoral and basic TKR loading, as they are the real life phenomena. But the analysis time for these two is again somewhere between 1 hour to 2 hours, which is very significantly low in terms of what you get at the end. The most useful in terms of the time saving will probably be the wear simulator, where you save the time from like 8 to 12 weeks to just a few hours. I guess Arindam has already talked about it, so I'll not take much time. I mean, of course, having Prabha on our side, who was also involved in the development of AKS, makes us very strong in terms of understanding. And if you face any issues, I mean, he's always very helpful in those things. So. Right. Yeah, I just wanted to finish this quickly. So thank you. And if you have any questions, please shoot them now.
Hello, this is Arindam here again. Thank you, Nishant, for the presentation. So we have it open for any question and answer. So You can type in there, so we will read it loud for everyone to listen, and then we'll try to answer to the best of our judgment and knowledge. So the first question is, have you published any work, or is there any resources on the simulation of soft tissues? Yes, we can. No, we haven't published as a company, but we can send you some information. There are published work, so we'll send you information there. Thank you.
Can you use native CAD files for
Yeah.
import? Yes, yes, you can.
Yeah. And also one thing is I want to mention, so in AKS, if you it has a default mesh, but if you want to refine your mesh, you can always do that separately and then bring that model up. And that's sometimes it's probably needed, so you need to look at your specific design, and there may be some features you want to model with the more refined meshing. You do have that option. Another question is, how does AKS tie into the current suite of Simulia products in terms of pricing, licensing, and token use? So Ali, I'll have our Ali mention about that. He helps with our all licensing requirements.
Sure. So like for AKS, you need a separate license, which is like an add-on to your existing Abaqus license. So if you want, I can provide you, I'll take that note and I'll provide you some information about the licensing cost. So if you already have an Abaqus license, then you can add it on. If you don't have an Abaqus license, you have to also get an Abaqus license, and I can share like more detailed information about this in a separate email.
And one thing maybe related to the same question. So if there is a portfolio solution for Simulia, so where you can use most likely it will be iSight, which is basically workflow automation. So you want to do a reliability study, things like that. You can use iSight and make AKS as part of your workflow. We will provide you some information on that as well. And I think we did, Nishan did mention it. I'm not sure I heard it, but so we do. So this is in they're already, so Simula is already in working with FDA, and this is for the MDDT. They are in the advanced stage of approval, where now they are getting into more details of the approval process or licensing process, I guess. For use it in lieu of clinical trial. So it's very well qualified solution. Is the wear simulation done through FeSafe? Now, FeSafe is mostly for a metal wear. Now, if you want, you can take the stress ranges and do through FeSafe, but it has its own wear module and it uses its own formulation for that.
Yes, I mean, just to add on that, like we mentioned, we have two different laws, the Archer's law and the cross-shear law, which are inbuilt in AKS. So we do it through AKS itself. Do you offer training in AKS?
Training wise, we haven't, we don't have a training program specific to AKS, but if someone is interested, we can definitely provide you a customized training. Because depending on your experience, it might be a little bit of Abaqus as well as AKS, or if somebody already has a very good grasp of Abaqus, then it will be more showing you the workflows in AKS and maybe some caveat as well. So,
the metallic components within the AKS are assumed to be rigid bodies, correct? Yeah. So the femoral component is assumed to be rigid body. Yes.
Yes.
I think this is for Ali.
So the purchase of those needed tokens, what would be made through Simulia or VIAS? If so, is it just the standard cost of the Abaqus license?
So we are a Dassault Systems partner, and we resell Simulia, so we can help you with that. So the configuration is that like you need a license, you need a CAE plus some tokens plus the add-on of Abaqus Knee Simulator module. So it's not just like the standard cost of Abaqus license. You would need to have the pay for the add-on which, called AKS. So I'm noting your name, Mohammed, and I can reach out to you in a separate email about the cost aspect of things.
And one thing I want to mention as a company, so we are a value-added reseller for Simulia and Dassault system in general. So we do provide pre-sales and after-sales technical services, and also once you purchase the software, if there is a technical issue, we are the first line of defense, and if we cannot solve, then it goes to Dassault. We have people here. One of our team member I mentioned, so he was at the headquarters, Dassault headquarters, of solving all the critical problems for more than 10 years of experience. So most of the time we'll be able to help you out very quickly. And also for our customers, for our software customers, we do provide some basic training on it. And we have other complementary services that we try to help them to effectively use the software. And I'm waiting maybe for a few other questions in the meantime. I just want to mention also that if this is just an example of one application, but Simulia generally is very, very good for life science simulations. So, and we are planning more webinar on that, but if you have any question related to life science simulation or any other applications, do let us know. I will be more than happy to talk to you about your requirements, why simulation, how simulation can help you.
Okay.
Can models be imported from SolidWorks? Yes, you can import models from SolidWorks. In fact, mostly the models are actually imported from CAD.
Yeah, generally the model, yes. I mean, CAE geometry, I mean, I think Sketch is probably not a good option anyways. So you will use a CAD software, generate the model, and then we can bring it as a step file. Okay.
How does the auto mesh function work? Right. So the Abaqus, the AKS tries to mesh your both all the components you import, and it's mostly a tetrahedral, but the region where contacts are happening will be meshed using hex mesh technique. And having said that, you also have the option of meshing your implants before bringing into AKS.
So it will, I think, and maybe Nishant or Prabha, you can correct me if I'm wrong. So it will try to know when you import it that how much the area will be in contact, and try to put more sort of brick element in there. But if you have a concern that it might slide more and all, you can define your own regions and define your mesh for that.
Yes, I mean, if interested, we can always talk about this offline, and we can show things how these things work. So let us know, Sinhu, if you are interested. We'll probably show you offline this one.
Does AKS have the ability to add custom soft tissue constraint not included in the base model?
Prabha, yeah. Okay.
Yes, it's a standard CAE model. You can add any new features in it.
So I think the way it is working, it gives you, it helps you with it. I mean, because once you automate something, and I also am involved with a lot of other automations, software automations. There is a basic, like a base level that it has automated, but it doesn't take away your liberty to include something in the model or refine something in the model. Generally, that's how all these automation wraparounds work with any sort of FEO or CFD software. So yes, and the answer is yeah, you can do that. Prabha?
Wow, okay. Can you elaborate on Archer's law versus cross-shear law and when to use each? So, Prabha, do you want to take this question?
Yes. So, if you use Archer's law, the wear will be used symmetrically depending on which direction the components are moving. In case of cross shear, the wear results will be a little more if it is moving in the cross direction versus linear direction.
Yeah, and I think it's also you need more data for the cross shear. So if you have those data, that can be sometimes.
Right.
Yeah.
Yes. So you need some constants that are required for implementing Archer's law and cross shear law. If you have access to either of those two, you can use either method.
We are here, so if you have any question, please let us know. We'll keep the webinar open, so no worries on that. And we'll be sending a follow-up email with the recording as well. And in general, as I talked about our capabilities from simulation side of things, and also our relationship with Simulia. So if you have any software need or any need for a simulation, let us know. We'll be more than happy to talk with you and help you with your requirements. And thank you for attending. Thank you for your time. And hopefully you found the webinar useful, and at least it gives you a pointer to ask for more information or think about something that you might think that yes, I can do simulation and it will help me. Audio is not working, so yes, sorry, there is one someone's audio is not working. We try to see from here. Okay, thank you very much. From okay. So okay, can you one more question is, can you also use this for other joints? So AKS is typically for knee, but Abaqus is capable enough to, I mean, to be okay. So my understanding is AKS is a wrapper. So even if you don't have AKS, you can do everything that AKS is doing. So others, there unless there is a wrapper there. For spine, there is some information available I can share with you, and also the hip. But you as long as you have the workflow, you can use Abaqus fairly easily to develop that. But we'll take that question, and I'll try to find out more information. But in general, the power of the software is always available to you, and as long as the workflow is defined. So for hip, joints, and spine, there are workflow defined already, so you can use that very easily. Micro motion. Prabha, do you want to take this one? Can AKS also model micro motion of the tibial base plate and tibial insert interface?
Yes, so there's two options for those. You can either model them as fixed, so there will be no motion between the insert and the base plate, but there's also a rotating option in which the AKS allows the motion between base plate and tibial insert. And how that's modeled is there is a stiffness specified in the rotation directions that determines how much rotations will be allowed depending on what the internal external rotation torque is.
Thank you. Implant and bone cement. Prabhat? So what?
Yeah, I'm not familiar with the implant bone cement interface, but something. How can I implant bone cement interface? So, so I think he is referring to how the implant is inserting on top of the bone, and that part is rigidly modeled. So the component, there is no motion allowed between the implant and the bone at this point.
Yeah, and if you have any specific problem, maybe you can explain as a problem you're trying to solve, then please feel free to send us an email. We'll also check with other experts as well.
Yes, I mean, that's something that we have all the components available.
Yeah.
If you want to specify a behavior between the two components, it can be created.
Yeah.
Okay, I see another question. Yeah. Can AKS do patellofemoral joint simulation alone? No. For we need the tibial component and the force that is applied on the patellar tendon for the overall simulation to work. Next question is, can AKS do UKR? Currently, it's set up to do only total knee replacement mainly because of the way the model is aligned, how the implant is aligned with respect to the bone geometry. But that's something that can easily be changed with an AKS. So once you have a default model set up, you can replace the geometry, and we can work around some of the constraints to get it to work. Yes. Next question is, can the native patella be modeled within TKA? Yes, both patella as well as the patellar insert are modeled within TKA, total knee replacement. So most of the patellar insert will be inside the bone, but if there is any protrusion, both bone geometry as well as the patellar insert will be in contact with the femur in the model.
As we have mentioned, if something comes up in your mind later on, please do not hesitate to contact us.
Another question is, are the bony structure in the AKS deformable? In the default model, they are modeled as rigid, but they can be specified a behavior, a bone behavior, and can specify a constraint between the bone and the rest of the geometry.
Yeah, there is a request for licensing related information, so we'll be more than happy to send you all the information. We have noted down your request. Thank you.
Okay.
So one more question is, what kind of patient-specific information needed for the model? Maybe Prabha, you wanna answer, but I think we also work with, there is a company called Simpleware, so where you can easily take a CT scan and develop a model, meshed model from it. So we definitely can use that one, and I can send some information on it. Prabha, do you want to add anything?
Yes. So in terms of patient-specific information, you mostly will be looking for importing the patient-specific bone geometry. And in addition to that, a tool like Simpleware can help you project where the insertion points will be for ligaments and bones, and we can use that patient-specific information to edit the model.
Yeah.
And some of it Nishant showed in this presentation, that there is an option to edit the attachment sites for ligaments and muscles, and those can be actually not just manually deleted, but also imported from a text file.
Yeah, and from the Simpleware side, it's basically if you have a very complex geometry, it can help you mesh that one. So I will send some information on that as well. Yep, and thank you all. If you, I'm still keeping it open for next couple of minutes. So if you have any question, please feel free to type in. We are still here, and then I will probably close the window for the webinar, and we are always available. So this is just the initial touch point. We'll be more than happy to carry on the conversation. And Nishant and Prabha, thank you. Thanks to both of you.